saw basic ideas in TensorFlow library. So now let me show you some examples. Whatever I'm showing you, I'll be putting it as a handout later today. So like I said, if you can understand the concept, and then you will try these yourselves, and you'll see it's pretty straightforward. Okay, so let me quickly show you the handout, what it looks like. And I'll probably refine it a little bit further, but okay, so anyway, the first thing is, of course, you have to install TensorFlow. If you already are using TensorFlow, it's already set up, then ignore the first part. But if you have not, then there's different ways of installing TensorFlow. My recommended approach is to go through Anaconda. When I wrote this handout, the Python version was 3.6. Of course, now you will do it with 3.7. Okay. So you install Anaconda first. Then after it's installed, then here's the best option in my opinion. Okay. So there are 3 commands you will type through the command prompt. Okay. So once you go to the command prompt, if Anaconda is already set up to the path variable properly. Okay, so first you do is you create an environment, and you can name it anything you feel like it. So for example, if I say conda create -n for name, TensorFlow CPU, or you can call it my TensorFlow, doesn't matter. Pip Python equal to, of course, 3.6 will get replaced by 3.7, right? Then activate TensorFlow. So we'll activate this environment. So this has to match this one. Okay, and lastly, you have to install the TensorFlow in that environment. So from the same environment command prompt, once you do activate TensorFlow, it will change to something like this, TensorFlow, right? TensorFlow CPU, and then you do pip install, ignore installed, upgrade TensorFlow, and it will install the TensorFlow. So 3 commands. Okay. Once you run these 3 commands, then if you're using Visual Studio, then you'll follow what I'll just show you in a second. So then if you create, for example, a new project, or doesn't matter, let's say one of the projects. Okay, so if you go over here, view, other windows, yeah, other windows. There should be like Python environment, Python environments. Anyway, so if you go to view the Python environments, then over here, all the Python environments under the Python environment tab will be listed. So the TensorFlow CPU will be one of the options. Then all you have to do is click, and then you will see something over here. Make this default environment for all projects or something. So anyway, once you do that, then you can use the TensorFlow library, and all the imports, everything will work. Okay. So easy way, and I put it in the handout. So let me go back to the handout. Okay, so then I give you all the instructions, you create a new project, and how you will set this, the default environment over here. Okay, then here's our test code to see it's working. So this is a typical Keras code, so you'll see how easy it is. Okay, so tf.keras.datasets.mnist and mnist.loaddata. So three lines of code. You have the test data, the training data, right? Then using Keras, you can create a dense layer with 512 neurons, ReLU activation. Then you can also add dropout to it. You can add another 10 layers in the output with the softmax activation function. So Keras makes it even easier than Graph API. And then just model.compile, you pick the optimizer, pick the loss, and model.fit, evaluate, and that's it. So, okay, if you have a GPU on your home computer or laptop computer, you wanted to also install the GPU version of TensorFlow. Then what I recommend is create another environment. Again, going back to the conda. I called it TensorFlow, but you can call it TensorFlow GPU if you wanted to. Okay, so this is basically creating a new environment. And then once you do pip install, the only difference you will see is previously this was just TensorFlow. Now it is TensorFlow-GPU. So we'll install the GPU. Okay, however, running the GPU is not that straightforward. Okay, sometimes we require CUDA libraries. So typical errors you will run into is, okay, it will ask you some DLL is missing, which you have to set a path to. Then you have to go to the NVIDIA, download the CUDNN, and once you set up the path to it, then it will start to work. So anyway, go through the steps. Hopefully it will work for you. Okay, now let's take a look at the TensorFlow concepts. Okay, so you already know a tensor is basically a multi-dimensional array, right? So for example, this has a shape of 3, rank of 1, this is rank of 2, shape of 2, 3, and so on. So you guys all know this. Okay, here's the key thing to remember. Okay, the data types in TensorFlow are written using tf.float32 or tf.indate or tfd-in16 and so on. So those are the data, tf.bool and so on. Okay, and because our old code that we were writing was in NumPy, right? Now we'll be writing from now on in TensorFlow. So a few comparisons over here. For example, if you wanted to declare a 2x2 NumPy array, right? Storing ones in it, storing zeros in it, and ones in it. How will it look like in TensorFlow? Very similarly, just tf.zeros, tf.ones, right? Okay, if we wanted to sum along a particular axis, here we say sum the B array along the axis 1. So here it will look like this, tf.reduceSum and then whatever reduction indices equal to 1. So slightly different. Okay, shape becomes getShape as an example. I think shape might still work. But anyway, take a look at np.dot, for example. If you wanted to multiply two matrices, what does it become now? Matmul. And similarly, there's tf.add. Actually, I'll double check. I think tf.multiply also works. But anyway, so range operations are same as regular NumPy, so that's good. Okay, so now let's go through a few simple examples and see if they seem. So the first example, let me show you. So if we created a class, right? Here's our simple computation. So like I was saying, in TensorFlow, we create placeholders, right? So if you take a look, tf.placeholder, what data type, float, you can give it some name. You can call it A or P hold A, just for placeholder for a variable. Okay, so that's how we create a placeholder as we run a session. When we're running a session, through the dictionary, we'll feed data to it. So through the dictionary, we'll feed A, so that based on that, A can do some computations, right? Okay, we create a variable, we can initialize it to some value. Okay, there's a little bit you have to be careful. If you take a look at the B2 variable, it's doing B plus 2. Okay, variables are initialized concurrently. So sometimes it may work, meaning sometimes it may have a 4, sometimes it may only have a value of 2. So it's not a good idea to make this variable depend on somebody else. If you wanted to make it depend on it, make it part of the computation, not declaring a variable, which I'll show you later. Okay. So after declaring a placeholder, some variables, we can also declare constants. Like if you take a look at C, tf.constant, and you can give it some name. So in this case, this is an array of 1, 2, 3, and 6. Okay, so let's take a look over here. This is the computation we are doing. D equal to A times B plus C plus B2, right? So what is A? This will be fed to whoever is running this in a session. So for example, let's say A is 2. Then 2 times B. B is 2, so we'll produce 4. Plus C. But C has many values. So what it will do is it will make this automatically an array, meaning first time it will pick 1, so 4 plus 1 will become 5, plus B2. B2 is 4. Sorry, B was 2. So this was 2 times 2, 4, plus C. C was 1, so 5. Plus B2, which is 4, so we'll produce 9 and then a few other numbers. Okay, so how do we run it? Okay, after we define the computation, our typical code is to create a session, initialize the session, and okay, don't worry about the writer part over here. So let's see if you see this part over here. So this is the important statement. dres equal to session.run. Okay, the first parameter over here is whatever expression we want to evaluate. So we are asking TensorFlow to evaluate D. Okay, what is D? This is D, A times B plus C plus B2, right? So what does that mean? For it to compute A, what does it need to know? See, B and C was a constant, so it's already known. B2 was, this was 2, if you remember, we made it 2 plus 2. So A, if you recall, was our unknown placeholder. Okay. So if we feed it in the placeholder, so we're asking it to compute D. If you take a look at the computation graph, it's basically multiply A and B, then add C, then add B2, right? So B is already 2, so this is our placeholder. So we'll specify the placeholder, then it will go, and this is our D, so we'll evaluate D. Okay. So if I go over here, So session.run, we are asking it to evaluate D. Feed dictionary A with a value of 0.5. So anyway, so if you wanted to also view the computational graph, okay, then you can store the graph in some kind of output file, and then you can launch okay, after you, okay, in a file called myoutput. So once you launch the PowerShell, in the PowerShell, if you type this command, whatever the output file that it had produced, okay, then you go to the browser, it will give you the URL, which URL you have to go to, and now you can view that computational graph, okay. So anyway, if interested, we can do this, but that's an option, right? Okay, let's take a look at another example and try to compute roots of an equation, quadratic equation, right? So if you were given 2x squared minus 5x plus 7 equal to 0. Remember the formula for the two roots are minus b plus minus b squared minus 4ac divided by 2a, right? So again, we can express this as a computational graph. Okay, what will be the parameters over here? The placeholders?
x1, x2.
No, that's the answer.
X.
A, B, and C. Those will be the placeholders, right? Okay, so...
Professor, why not x would be the placeholder? Because we need to
No, because we're feeding in an equation, right? Based on A, B, C, it's computing x1 and x2. So that's the expression that needs to be evaluated. That's our answer. Okay, so let's see if you can see how this will be done. Okay, do you see the three placeholders for A, B, and C, right? For the fun of it, I declared it as a constant. Okay, if you take a look at root 1, root 2, these are the two roots. Does it look like the proper equation? Minus b plus b squared minus 4ac square root divided by 2a. Okay, 2c is just the value 2. If you see 2c is just the value. So this is the same, right? So again, how will we run it? In our dictionary, as we run the session, we'll have to feed in the three values, right? So if you take a look over here, take a look at this line over here. Okay, I fed in an array of data, but we could have fed in, for example, 1, A of 1, B of 2, C of 1, right? Which basically means it is x squared plus 2x plus 1. So as you can see, this will be x plus 1 squared. So the two roots will be -1 and -1. Okay, so anyway, session.run roots. So we are asking it to evaluate roots. So what is roots? Let's take a look.
the equation.
Okay, R1 and R2 were the two roots, right? So basically I assembled it into a list. So we're saying evaluate this. Alternatively, I could have said like, it will also work if I go back over here. Where did it go? Okay, alternatively, instead of roots over here, I could have said evaluate R1, R2, and feed dictionary equal to whatever, okay? So far so good, right? But no neural networks over here, no tensor were involved in a way. so now let's go take a look at a neural network example. So let me now take you, okay, that was just the main, and you can see the answer, and you can see the graph, no big deal. Okay. Okay, so basically what we'll do now is we'll create a simple network. Okay. So I wanted to pick a smaller example. So there's an iris data set. Some of you might know about it. It's a very simple data set. It has 120 training data. And so basically 4 features, like the width of the flower and so on. And there are 3 classes overall. Okay, so if I show you very quickly the Excel for it. Okay, so as you can see, okay, so this is what the data looks like. It has the length, the width, the petal length, width, species, and there are 3 species over here, so 120, right? So on purpose, I wanted to pick a very, very simple example so that you guys are not running through minutes or hours of your CPU time. So very quickly, you can see the results. Okay. So, so once again, we have 120 data, 4 features. So these are the 4 features, and 3 classes. Okay, so what we'll do is we'll do one-hot encoding of the output data. So for example, if it belongs to the first class, output will be 001. If it belongs to the second class, output will be like this. Belongs to the third class, so this is called one-hot encoding. Okay, so let's take a look at the TensorFlow code for doing a classification on the iris data set. And by the way, the test data has 30 data items. Okay. So anyway, once you get it, you will try it yourselves. You can either download the CSV, open it from your local file, or they give you a URL also. Okay. So using Pandas, which is one of the libraries, it's very easy to read a CSV file. Skip rows equal to 1, because if you see, the first row was basically the names of the columns, right? So anyway, once we have the data, okay, we can now, the last column, if you recall, was the class labels. So the species column we are dropping basically. From the training and the testing, so that we can, anyway, so then we do one-hot encoding. So this is the code for that, pretty straightforward. Okay, so I took this example from the internet, but I modified it significantly to our needs. I thought somebody had done a very good job in evaluating the architectures and displaying the loss. So that part of the code is similar, but what we do inside is quite a bit different. Okay. The idea over here was, let's analyze the neural network architecture. We had 4 features, right? So there will be 4 inputs. Okay. Then how many hidden neurons do we use? 5 might be one option, 10 might be one option, 20 might be one option. So this way we can set an array of hidden nodes and create 3 architectures and run them through TensorFlow. Output, of course, will be 3. Why 3? Because there are 3 classes in this particular problem, right? Okay, so like I was saying, the neat thing about TensorFlow is we just create the forward pass. We write all the equations, and then we ask it to evaluate, for example, the loss. And once we ask it to evaluate the loss, so let's say we did something A1 equal to W1 X1 plus B1, then we did S1 equal, or sorry, S1, then we did A1, right? And then we did loss equal to something. So as we ask it, as we run the session, as we ask it to evaluate the loss, because one of the terms over here will be A2, so we'll have to evaluate A2 and so on. And of course in the feed dictionary, we'll give it the X data. So if we take a look at how the network is set up.
Excuse me, how many layers are in that model?
Just one hidden layer.
One?
But 3 different models.
Oh, 3 different models?
Yeah. So we have 5 hidden neurons in one, 4 inputs, 3 outputs. Then in the second one, 4 inputs, 10, still 3 in the output, and the last one was 20. So we wanted to evaluate 3 different architectures and see which one does best on this particular data set.
And why, if there's 3, why would there be only two weights?
Because if you take a look over here, right? This is W1, this is W2, only 2 bits. Even if it's this architecture, there will be W1, W2, but we'll store them separately. So this W1 and these W1, W2 will be stored separately. Okay, so let's take a look where were the equations. Okay, so basically this is our architecture. Okay. Where did it go?
We did not initialize the weight randomly, did we?
Okay, let me try to remember. Okay. Sorry, this is where we do. Okay. So let's go over here. So at this point in time, all we are doing is creating a list of 5, 10, 20, creating sort of a dictionary over here with 5, 10, 20 fields. There will be an array over here, and the 10 field eventually stored array over here, right? Weights, nothing specified over here so far, okay? Then we have the number of epochs. Anyway, then over here you'll see okay, so where did it go? For hidden nodes. Okay, so over here, if you take a look, this part of the code here. So we are basically, see, this was a list of 5, 10, 20. Okay, so weights for the one with the 5 hidden neuron. So there will be weights 1 and there will be weights 2. Weights 2, there will be bias 1 and bias 2, right? Okay, same way, once we loop it through the 10, it will store the weights 1, weights 2, and the biases in a different index over here. And lastly, for the 20, right? So what we are doing over here is we are calling a function over here, train model. And train model is where we will build all the forward pass equations. Okay, so very quickly, if I show you the train model. Okay, yeah, right here. Okay, for the train model, okay, so okay, we have two placeholders over here. If this is our network, remember we need to feed in the input data X and Y is our expected output. So because we had 120 input data, the placeholder for X will be 120 by 4. Placeholder for Y, there are 3 classes, but 120 will be this type, right? And then here, if you take a look over here, we are initializing these randomly to all the W1, W2, B1, B2 being initialized randomly. And now let's take a look at our equations over here. So this is basically the A1, A2. So I didn't put a sum over here. So basically TF.matmul, TF.sigmoid. So you can see X times W1 plus B1, A1 times W2 for B2. Okay, then we define the loss. Okay, loss, as you can see, is simply A2 minus Y squared. So TF dot square will do that in TensorFlow. TF dot reduce sum, if you recall in that table, was simply the sum in TensorFlow. Okay, now we can define the optimizer like gradient descent or atom or whatever. So I put comments over here so that you guys can play with both of those. And lastly, we create the session, we initialize it. Now, each time we ask it to evaluate, right? What it will do is it will go through it one time through the whole graph. So if we wanted to run it through number of epochs, we have to keep running it. Each time we'll feed it some data over here. Okay.
Professor, why number of epochs here is very high, 2000?
Okay, in the beginning I was using batch, I was using, what was that called? Gradient descent, no batch. So that's why I was put in 2000. Then I changed it to mini batch, then you only needed 200 then. So anyway, okay, so the key thing to, where did it go? Session.run train. Okay, if I take you to, okay, give me 1 second, where did the train go? Okay, yeah, so if you take a look at this statement, session.run train, okay, we feed in some X data, expected output data, right? Okay, which is the whole 120 by 4, 120 by 3. Okay, then if you take a look, we are asking it to evaluate this part, this expression over here, which is basically trying to minimize